Thank you. My name is Ryan Schoen. I'm a product manager on the Chrome Web Platform team.
Are you guys sick of me yet? I'm here to talk about speed again. I'm Nat.
Yep.
Been doing this for a while. Probably going to be doing it for a while yet. Chrome's not fast yet. Should be.
And as we were taking a look at the other slides for the other programs, we realized that we actually have kind of an easy job up here today, because we don't have to tell you what speed is. We don't have to tell you why it matters. Like, you guys are already all on board with this. And so with that, we're just going to jump right in. We don't, yeah.
Is everybody on board?
Because if you're not on board with this, yeah,
like just gone.
Find us.
Like,
So we're going to jump right in and just do a quick retrospective of 2016 and some of the major accomplishments from all of you. This is definitely not comprehensive. We don't have everything. It's alphabetical. I'm trying really hard not to offend people, but this is just a selection of some of the stuff that you guys have achieved.
It's my fault if we forgot you.
First up, background and off-screen throttling. So this is the idea that if something is not in front of the user, we should deprioritize it and prioritize what is in front of the user. The graph up here is a little hard to see, but it's power consumption on some key sites before and after we just turned off the rendering pipeline for off-screen content. And in some cases, this is, I think, like a 75% win, but on average over the cases, it's about a 30% win for power on Android with zero difference to the user.
Yeah, sure. Good patches.
Many of you know we started intervening against Document.write when content attempted to use it to insert a parser blocking script, which then used Document.write to insert a parser blocking script, which then used Document.write. Way too common of a pattern, often in third-party content like ads and analytics. When we stopped this from happening, especially for users on very slow connections who had to do that round trip, we found that not only did successful page loads go way up, but the time it took to render that content or to get that content in front of the user went way down. And not only did we intervene for that user in that moment, but we found that over time, we decreased the number of page loads that were even attempting to do this by 15%. So we actively moved the web ecosystem away from this bad behavior so that all browsers benefited from this.
I mean, we've been talking about this for every BlinkOn that I know, the great evil of Doc.write. So, like, again, round of applause for the folks who did this. This is really cool. Finally, it'll go away, maybe, hopefully.
Desktop power reduction. So this is an area we've been working in for a very long time. And this past year, we were able to make some major improvements, especially around video and animation. So this is a graph, I think, on Mac of Chrome over time, just of a fraction of its own power usage on some key cases. You can see it's dropped way down. It's not zero-based, so you can yell at me for that. But we want to keep driving this down. Most of the improvements have been made in the GPU. We want to keep driving down CPU power usage so that people can watch Netflix for as long as they want to. Font glyph cache optimization, excuse me. This was a great write-up. You should go and read. It's public. Bitly glyph cache optimization drove down page load time, which is that top graph, and memory usage as well, anytime that we were using web fonts.
Yeah, one thing I love about this is the way it was done. We see a lot of speed projects that are quick, get it done, do it, and move on. But there's really great documentation, really great metrics work, really great sort of putting this in context that was done by Koei and the folks who did this. So really great work on this.
Garbage collection during idle time. So this is V8 going back and collecting unused memory anytime that we detect that there's a chance to do so. This is a great win across almost all sites, but especially really heavy web applications. When we launched this, we took a look at Gmail, and after only a few minutes of using it, we were able to save over 100 megabytes of memory on desktop just by doing this when the user wasn't touching Gmail, which is incredible. Intersection observer, another kind of anti-pattern that we see with a lot of third-party content like ads and analytics is that they will just constantly pull for viewability. Is my element visible? Is my element visible? Is my element visible? And so we decided to implement intersection observer, which flips that around, and you can just subscribe to notifications when your visibility changes. We see the usage of this API taking off, modulo a holiday dip there. And at the same time, people doing this in less web platform friendly ways like Flash is dropping. And so we're switching over people to doing the right thing here. As I think Rick mentioned this morning, we launched Lighthouse, which is an auditor for progressive web apps. Certainly a lot of performance stuff there, a lot of other stuff for how to be a good progressive web app. It's available today as an extension, and we're integrating it into DevTools. Motion Mark was a benchmark that was released last year that had a ton of rendering use cases. We really dove in deep on this one, and I think we got 25% improvement overall on our benchmark score, 38% when you restricted to mobile. And if you looked at certain of the categories, I think there was like north of 1,000% improvement on some of the areas. So this was really great in identifying places that we could just be way better in our rendering pipeline.
I like 1,000%.
10x it. Speaking of benchmarks, we also took a bunch of effort into optimizing Speedometer last year, which is a benchmark that opens up a real-world app written in a bunch of frameworks and just iterates through it. And so this is about a 25% improvement over the course of last year. And we think that this does actually generalize very well to web content that's out there, real apps. And I think the V8 team is going to talk about this a lot more today, so or maybe tomorrow. So I'm not going to go into too much detail.
Well, and a big high five to the V8 team for transitioning from Octane and benchmark-driven development to real-world data and real-world websites and really focusing on the user. That's exactly kind of what we want to do to make our users happier.
We just had a blog post go live yesterday on the Chromium blog, so check that out. It includes this, which is partial tile redraw, just making sure that we're doing as little work as needed in order to get the right pixels on screen. It also talks about a bunch of other stuff, such as hardware rasterization, which we've been launching to more and more platforms. Emil, this morning, I already talked about this. This is passive event listeners. The idea is that websites such as CNN, which you see here, can subscribe to touch events, run some JavaScript, and because we don't know if they're going to cancel the scroll or not, we have to wait for their JavaScript to complete in order to scroll the page. With passive event listeners, developers can say, I'm going to do my JavaScript. You just go ahead and scroll. And you can see it makes a much better user experience on the right there. And as Emil mentioned, we can go even further and just do this on behalf of developers when we detect that it's probably safe. It's not going to break the page, and the user is going to get the benefit without the developer having to do anything.
Isn't that a nice instant replay there? Like nice slow-mo. I like it.
On Windows, we implemented performance-guided optimization, which is a compile time technique in order to compile and organize the binary in a way that is most efficient for optimizing the metrics that we care about. And so we had huge improvements across a number of key metrics here. Again, the user gets for free. Progressive web metrics is a concept that you'll probably hear a lot about over these 2 days, but it's the idea that we should focus our metrics on the key performance moments that are critical to the user. So in this time strip of a page load, you can see that we've identified kind of the 3 key moments. The first one is what we call first contentful paint, the first time that there's sort of that splash of content of anything on the page. The second one is first meaningful paint, which is the content that the user wants to see. That's why they're going to the page, and that's when it's on screen. And the last one is time to interactive, where the user, if they were to scroll, can scroll the page, and they believe that the page is scrollable. It looks done enough that they think that they can do that. So these are very hard things to measure. Mostly we can only get at it by heuristics, but we've been working in order to get these metrics so that when we optimize page load performance, we're doing it on the metrics that matter. And we want to take that and apply it to every aspect of performance this year, not just page load time. For users in emerging markets, we wanted to take a good hard look at pages that were super slow. And so when you have data saver enabled, now what we're going to start doing is showing a simplified version of the page that is much easier for them to load in a very data constrained environment. And we're seeing that with this change, as well as some other changes in data saver, that pages can load up to 2 times faster with 90% less data used. And that's critical for users in these markets.
So this isn't exactly a web platform kind of a feature. Like we don't usually do this in web platform, but you can think of this as the ultimate intervention. But we put this up here because this is one of the few speed things that we've done over the last 5 years that really has a transformative impact on the user's perception of speed. So like GPU rasterization, when that kicked in for the first time, it was just way better for certain experiences. Or I'm trying to think of some others. We've done a couple of these where it's just like, wow, before and after. This is another one of them, V8 originally, right? This sort of work, breaking the content because it's not the right match for the user's device, it's a powerful thing in terms of what the user experiences. We have to figure out how to make this work for the web. It's going to be a hard project.
Many of you have probably heard about memory infra. If you haven't, find someone here who works on it and talk to them about it because it's incredible. It's deep instrumentation of all of our memory allocation sites in Chrome, and then the tooling to roll that back up so you can understand where Chrome's memory usage is going and how to optimize it. And it's totally just a coincidence that the moment we launched this tool, memory usage on Android started, Chrome for Android just started plummeting and hasn't really regressed in the wild since then. And so we want to take the lessons that we've learned from this and apply it again to every aspect of performance across every platform so that we can see graphs like this, the theme of this morning, down to the right on all of our performance graphs.
Yes, please.
And so, wow, that's awesome performance. But I just want to take a moment and congratulate and thank all of you for the incredible work you did last year.
Yeah. Hey, high five, everyone.
And that's where the optimistic part of my presentation stops.
Which is why I'll start talking more.
Because there's still a ton that we have to do along these dimensions and more. And so just to give a quick overview of how I'm thinking about this from the product level, and then I'll turn it over to Nat again to deal with the actual details of what we're going to do here. On Windows, again, as I said, no surprise, we want people to be watching Netflix for as long as they want to, and so power is something we're going to have to continue to work on in order to get right. We also have the challenge of memory on Windows, since we have the Windows ecosystem has a huge number of devices, many of which are very low memory, and so we have to deal with users that only have a few gigabytes. And additionally, we have to serve very diverse user populations. We like to think, working at Google, and I'm sure many of you, that like the 30+ tab use case is really important to optimize for. So we have to do lots of things with discarding tabs and making sure that we're throttling background effectively. When the vast majority of our users, I think, have 4 tabs or fewer.
Here's a random idea. So how many people have 5 or less tabs open? Raise your hand. On your desktop, not your phone, right? Okay, 10 or less, 20. You don't know how many. Okay, basically, yeah. We're not like the real world here. Like we use a lot of tabs. And we like to think, therefore, that like high tab is really important to our customers. And it certainly is for a population. And we need to do better. But 2 or 3 is kind of the typical number. It's about, what, 50%, 60% of our users. We got to do good there, too, on Windows. That's a big problem. On these Windows El Cheapo notebooks, there's a memory problem, and it doesn't have to do with them having 50 tabs. I mean, come on. So we need to work there, and we need to think about what our users are experiencing, not just what we as programmers are experiencing.
On Mac, largely a similar story. We want to continue focusing in on energy consumption, as I mentioned. WebKit continues to be a very formidable competitor here, and we want to stay competitive as well. I stole this other photo from a colleague. This is the Windows 10 launch announcement, and you can see the press there taking notes, taking photos on their MacBooks only. But this is really important to us because not only do we want to nail our Mac use cases so that we can just deliver for those users, that tons of users we have on that platform, but our entire public perception from the press for Chrome on desktop is Mac, because this is what they're using, this is what they're testing on, this is what they're writing about. And so if we want to win both the user story and the public perception, we need to focus on Mac.
It's the touch strip performance. Is that what it's called, the touch strip? That's what we have to do, 60 FIPS on the touch strip. That's going to fix everything. Or we could work on extensions, I suppose.
Yeah. Extensions. We think this is we know that this is a huge blind spot for us because it provides great extensibility to Chrome, provides features that we don't have natively in Chrome, but it is detrimental to performance and security and privacy and stability. And so we need to make sure that when users are installing extensions, they know the trade-offs that they're making. And we also need to catch those like pathological interactions. I've seen so many performance bugs filed, and we dig into it, and we find out that it was a totally benign extension just interacting with Chrome in a way that it had never expected to, and really tanking that user experience and making it horrible. So we need to make sure that we have coverage over the extensions. On Android, every aspect of performance matters. These are very limited devices in a lot of ways, and so we have to do page load time. We have to do power. I'm calling out memory and responsiveness here at the bottom because we think these are 2 of the things we really have to get right in 2017. But it's true, we have to hold the line on all fronts really in performance on Android. And it's decent in the United States at least, and other developed nations, but things get even more constrained when you get to emerging markets. And so this is a huge focus for us on Android. We have low memory Android devices, which we think is like 512 megabytes and less. And for those, we actually have a different compile time mode of Chrome that we go into where we do extreme memory saving operations. For devices that are just outside that, like at 1 gig, these are still very memory constrained devices. But for some reason, we're turning off those optimizations. And so we want to move away from this compile time choice of your high memory, your low memory, and more to runtime decisions that we can decide based on the amount of free memory and the memory pressure signals, which optimizations to do, whether to prioritize memory, or speed, or other aspects of performance.
This is another example of our phones that we have in this room are not the real world phones. You know, just we got to keep an eye on the real world.
And then another, another huge challenge in emerging markets is data consumption, both from the perspective of data is very expensive, but also from each additional bit is going to make that page load that much longer. And so we really need to be cautious with data. And I think that's something that the browser, maybe like Chrome browser has thought about a little bit, but that Blink and the platform team has not thought about as much.
Yeah, we don't often have talks here about how to save bandwidth. It's not really something we've talked about. Maybe we should. You know, scalable loading, I think, is poking at this finally. Maybe we should think harder.
And then again, I talked about this already a couple times, but we have issues with third-party content like ads and analytics that developers are dropping into their page because they get some concrete benefit out of it, whether it's monetization or some information. But they also can't reason about the trade-offs that they're making when they drop this in, be it performance or otherwise. And this is even more, again, compounded in emerging markets where users are paying data to see these ads. And so a lot of times it's delaying the page views for very long, or the page load for a very long amount of time. And so we, as the user's agent, we need to figure out what we can do there intelligently in order to make sure that the user can see the content, they can get to the page in a performant way, but the developers can still monetize on that content, because that's not something we ever want to break either. And now for the actual details of what's going to happen.
Well, I don't know. I have no idea what we're going to do. But I have a few thoughts. First of all, we could just say, that's the problems, go, I'll fix it. We've actually got a lot of people who work on speed. If you remember, I did that survey a while ago of how many people are working on speed projects and what they're doing. A lot of work, a lot of really exciting work. It's a little disorganized. And so what we're trying to do for this talk is provide just a little bit of structure, a few sort of goalposts to help inform the discussion. And we're also here now kind of saying we want to help wrangle speed because we want to head off this hero syndrome that we see. We've actually made Chrome faster a lot over the last couple of years on the backs of heroes, people who went above and beyond to find a 1 gig memory leak, even though it wasn't their job. We actually did have that. We want to get to a point where we're systemic and very sort of structured in our approach to speed so that we can really, really, really do a great job at making Chrome and the web platform super, super fast. So that's the purpose of the speed program is really, instead of me talking about some speed projects I'm excited about, talk about speed holistically along with Ryan and try to wrangle it a little holistically. We use speed because we needed a word that was encompassing, and there isn't one. Data, usage, PLT, like there are lots and lots of words for things where you're tuning a number. And we're using the word speed because Chrome has this thing about 4 S's: speed, simplicity, security, stability. So that's the word we'd use. Any other company doing this would call it performance, whatever, it's speed for us. And these are the things that we think we should really focus on for this year. These are 3 sort of bullets of text. You guys can read them. What I think we want everybody to walk away with is sort of these 3 words in their heads about what good speed work should be thinking about, how good speed should be throughout this year. First, we should be thinking a lot more about understanding and analyzing speed, not just making it faster, but just digging in, understanding. Second, we really need to be thinking about our operational aspects of speed, preventing regressions being the most important thing. We can't make Chrome faster if we get slower. And finally, we need an architecture for speed. We have an architecture for the message loop, for example, but every team has sort of invented their own solutions to speed in their own little microcosm, so they don't add up. Details. We need to nail analytics. There are too many projects that we listed as great accomplishments that didn't do sort of the groundwork to understand what are our consumers facing with data. One of the reasons that the memory infra project is something that we talk a lot about is because that effort has done a lot to just understand where memory is going without the intent directly to move it. When you do that, you find surprises. Like we had 6 months of a 1 GB memory leak on Windows. It was actually more like 4.5 GB in the browser process on Linux. I mean, this is huge. And you only find it not by trying to do your feature, but by trying to understand. So we need to really focus on that. And there's going to be a couple people, Tim Dresser especially, trying to rally our efforts here. We also have to stop regressing. So one thing we did last year is we tracked the number of times we accidentally shipped a regression to stable. And it's kind of scary how often it happens. We were able to stop regressions of memory on Android only, and everything else we gave up on because it was too hard. One of the sort of roots of this evil, we think, is that we've actually succeeded too much at benchmarking. We have a gazillion benchmarks on our waterfalls, and you'd think from that we're preventing regressions. What's actually happening is those regressions are things that measure projects that we did, that are done. They're not designed for coverage. Like when you do a performance test, we think about measuring our project, but when you do a unit test, you think about preventing regression. And we need to kind of tweak our mindset around benchmarking to be about, how am I going to prevent my team, my piece of code, from regressing by accident? Not, how am I going to get my feature launched and have a number to show for it? That's good. But preventing regressions is absolutely critical. And so we're going to be pushing hard on operations. And if you want to know more about that, talk to Annie Sullivan, who is somewhere in the room. Definitely talk to her. And he's in the back. And finally, this architecture thing. So there are lots and lots of speed projects that are just optimizing a particular thing. And those are really, really important. But we have a variety of projects: Lucky Luke, Global Coordinator, Global Tab Coordinator, Memory Coordinator, PCU, tracing, what else? Sort of a gazillion of things that are sort of cross-cutting that we all use, memory infra. But they're not architected together. We coordinate memory with a different piece of software than we measure memory. We measure tasks, and then we schedule tasks, and we have 2 task schedulers, one for base and one for Blink. This needs to get coherent. We need to take all of these different pieces and make it look like it was designed by one room of people working together. The goal of this system is to build that smarter engine, to make sure that all of our pieces, all of our smartness in each of our pieces of code can be coordinated and tuned to get the best performance for our user, and to measure and to sort of ensure that we have a consistent Chrome-wide measurement of our speed. What exactly this architecture for speed is, I don't know. But you can kind of think like onion soup once was a big generalization of our layering. And we came in and we knew that we wanted to clean it up, and then we sort of discovered what the onion soup is over time. And this is sort of going to be like that. We need to discover together what the architecture is that allows all of our different speed projects to coordinate and measure each other. So we're going to be spending a lot of the time at this BlinkOn in breakouts and in sort of huddles, talking about what the global resource coordinator might be, what the architecture of our speed is, so that we can be sort of awesome together at making Chrome faster. So those are the things we want to do: analytics, ops, architecture. If you want to talk about that more, you can find us. I don't think we're doing questions.
No, we're not there.
But that's it. Thank you.